I just want to welcome everybody that's joining us today for, again, I think the last in the series of webinars that Tennessee Tech has basically been putting together. So I'm really delighted that we were invited. So it's going to be a joint presentation. My name is Wosczyna-Birch. I'm the principal investigator and the executive director of a National Science Foundation center called the Regional Center for Next Generation Manufacturing. And I also direct a statewide program called the Kaushik Technology. And joining me will be Eric Flynn, who is a principal investigator on a project NSF grant that really has done some great stuff with integrating professional skills in additive manufacturing. So with that being said, let's just move on here. Maybe have to use arrow. Okay. Just quickly, just to kind of give you a sense of who we are, Kaushik Technology basically is a statewide legislatively created collaborative that includes all of our 12 community colleges that are public, so there's 12 of us, and with that we provide seamless pathways with our university partners, and we have a lot of involvement of industry to make sure that we're meeting with workforce needs and making sure that the students that graduate from our certificates, our associate degrees, and ultimately the bachelor's degrees have the skill sets necessary in order for them to be successful in the work environment. So this is Connecticut. In case you don't know who we are, we're up in the northeast corner of the United States. This shows you all the different community colleges. There's 12 of us. And then we have 8 universities that are partners, official partners with our COT. One thing I would probably mention on this is that we really have access to a very diverse population. Collectively, our community college university system, actually community colleges themselves enroll over 50,000 students. Many of them are underrepresented populations in STEM. So this is fabulous in terms of, again, addressing the workforce needs. So our Kaushik Technology is, again, really the good example of stackable credentials. So we have certificates that are credit, associate's degrees that all feed into and transfer seamlessly to bachelor's of science. And again, our goal is addressing workforce, especially in manufacturing. So I'm going to just jump through this quickly because, again, this is really more talking about the programs we have in place. But I think what's important for today's webinar is that a major component of our associate's degree and certificates are focused on additive manufacturing. So we actually offer a standalone for credit additive manufacturing certificate, and courses that are included are an introduction to additive manufacturing materials, applications, SolidWorks, and then an internship in industry. So this is important for us because quite frankly, all of our community colleges probably do some aspect of additive manufacturing, but we also now have specific centers that are located at sites throughout Connecticut that, in fact, have additive manufacturing laboratories. So just quickly, this is our center. Our center basically is in its third year funding, and a major component of us over the course of the last really 12 years is to be really responsive to new skill sets. And without question, additive manufacturing since 2004 has really just taken off. So it's an area that we've been really, really on top of in terms of making sure that at the community college level that we are providing really those skill sets that allows additive manufacturing from going from prototype to now really production. With that being said, I was talking a little bit about industry surveys. We do an annual survey of manufacturing companies in the state, and this just quickly shows you a comparison of, what are some of the skills needed and what's the gap. And what we find is that often the companies are saying, the technical skills are important. Yes, we need additive manufacturing, but we also need professional skills. So that's something that has been really a focus for us in terms of our curriculum, and in particular, really being a resource both at the center level and also as part of a project you're going to hear about shortly. Okay, so I wanted to do just a quick little Manufacture Your Future video. If this was just kind of one of our videos we've done on our program.
From aerospace and medical devices to electronics and pharmaceuticals, advanced manufacturing is alive and well today in Connecticut. Where cutting-edge technology is making a difference for companies like Oxford Performance Materials in South Windsor.
Our primary technology here now is a process called selective laser sintering, or SLS, where we do direct digital manufacturing. So we can take a CAD file and essentially print a part that then has a functional use.
Our favorite is the custom implantable orthopedic device market, where we can make very specific repair parts unique to an individual's body. Typically, these would be replacement sections for a human skull, generally damaged by injury. Alternatively, other bones in the body, generally damaged by either injury or cancer or other disease, can be reproduced exactly.
So we were just trying to give you a quick little overview of, again, an example of a company that we work with that actually hires our interns that really does cutting-edge additive manufacturing, in this case, in the biomedical industry. And I would just like to add to that Connecticut has UTC, Sikorsky, Pratt, and Whitney, so we're big with aerospace. And we've probably been a little behind the West Coast when I think of Boeing in terms of the use of additive manufacturing. But seriously, in the last, I'd say, 5 years, companies like Pratt have really stepped up to the plate and recognized the value in using additive manufacturing, and therefore have come back to us and said, we need technicians that have these skill sets that allow us to be able to do not only prototyping, but actually production, and in some cases, even retrofitting parts, where they have parts that they have to repair, and they no longer can do the more traditional manufacturing to make them. I also just wanted to mention quickly, we have a whole video library that actually has different profiles. Another area that we've looked at is both trying to recruit women and veterans. So if you get a chance Friday night, pop some popcorn, go to our website, and I think you'd find them very interesting, but also are a great resource for you to use for both career awareness in a classroom, as well as if you're doing any outreach activities. So I wanted to just, again, go back to the additive manufacturing at our community colleges, just because I think we've got a lot of exciting things going on in the state. One of our 12 community colleges that has been a lead historically with really advancing manufacturing in the state is Nantucket. And back in June, they officially opened a 27,000 square foot advanced manufacturing center that now has a whole wing that's devoted to additive manufacturing and has the first additive manufacturing 3D printer. So we're kind of excited about that. Again, taking, I think, our education to the next step in terms of recognizing the role that metal 3D printing plays, especially in aerospace. I'm going to jump through these quickly. We're doing, again, additive manufacturing with a variety of high school programs. But again, what I want to make sure that we touch on is that all of the programs we're doing, in as much as we are teaching the technical skills, we have a very strong professional skills component that includes having the students working in teams, having the students actually go through really a workshop that deals with, how do you do self-directed teams? How do you really, deal with issues with respect to, accountability, showing up on time, making sure that they realize that, they have to also maybe do some project management, maybe do presentations. So all of our initiatives make sure that we integrate those skill sets along with teaching them the technical skills. So we have several project grants. Engineering Technology Challenge basically is a project grant that's focused just on high school students. So again, we have a little video clip. We do this on Saturdays with our high school students. Again, they do the 3D printing, additive manufacturing, and we were really excited because a couple of weeks ago, Channel 3 came in, did a little 45-second clip, and we're going to show that to you quickly. But the students they learned SolidWorks, and they were actually doing some 3D printed pumpkins. So we were kind of excited that they came in and showed this on the news that evening as well as the next day. So if you bear with me, we'll just give you a quick little snapshot of that. And unfortunately, anything comes on Channel 3 News, they have some type of advertisement. So that happens, I think, whenever you access things online. So the survivor, that's the way I feel sometimes, but that's necessarily
students from Hartford's Public High School's Academy for Green Engineering and Technology did their part today to give a little bit of a different look to a Halloween favorite. How about this? 3D pumpkins. That's right. The students, through the help of the folks at Texas Community College in Farmington, were able to create their own artwork as part of the Engineering Challenge program. 24 students from the school have been designing the pumpkins for the past couple of weeks.
It's worth it because it helps me become a better person to better engage with people that I know and see on the daily.
Now, the program aims to teach underrepresented inner city students the technical and professional skills they're going to need in the future.
Okay, so that program has been super successful with, again, trying to do that integration of teaching these kids about, team building, how to, deal with, we say difficult people, but certainly just the whole idea that when you get into the workforce, you're not going to be working in isolation. Everything now is done in teams. How do you manage your time? Also, they really have to, as they have specific goals that we set for them. It's a 6-week Saturday program they're there all day on Saturdays. But we tie a lot of these things also to a performance-based assessment. So it's a great program if anybody is looking for something to do to help with that pipeline and get those high school students to consider enrolling in manufacturing programs. Certainly contact me because we could share a lot of our best practices on that. With that, I'm going to move on to our college program. It's called Netsquared, Mechanical and Manufacturing Engineering Technologies. Has 4 goals, again, skill-based curriculum, but we really, in this case, pair community college and university students in team-based learning, and basically part of that, again, integrates professional skills. So they learn a lot of the technologies, but with that being said, we go back to making sure that we, on a daily basis, have some of those professional skills that industry keeps saying are missing from students who they employ. So with that being said, I'm going to just go over the whole program here on this slide, and then I'm going to turn it over to Eric, who is one of our professors in this particular project and the PI, in fact, of this particular grant. So anyway, we have, again, the green in the middle, the technical skills. So you're going to hear a little bit about the specific projects we're doing that in particular integrate additive manufacturing. But we also build in an entrepreneurial piece because many of these teams, again, they're led by students, but we do have often an industry or a faculty member that is the mentor for that particular project. And again, as we mentioned since the beginning of this presentation, a key component of this initiative certainly is that professional skill and how we can make sure these students really graduate not only with the technical knowledge, but with also professional skills, which include the team building, the whole emotional quotient concept, strategic management, which is really significant for them, time management, goal setting, and then we also throw in some advanced memory techniques. So it's really been very, very successful. If any of you have gone to high tech, we often bring these students with us and have them do presentations. So I think, again, it's kind of a nice example of really just making sure that they're very well-rounded. And honestly, many of them in their interviews, when they talk about this MET program, they'll come back and say, that made the difference in terms of me being actually employed versus somebody else. So this is the timeline of the MET project. The students, basically, we recruit them in the fall. They spend a full winter session, which is 2 weeks, between December and January. And during that time, again, we do the professional skill education, and also the students learn some SolidWorks, and they choose during those 2 weeks which teams and projects they want to be part of. And then they spend the whole spring semester actually working on those projects in these self-directed teams. And then at the end of the spring semester, we actually do a statewide presentation where we bring in legislators, administrators, our fellow faculty, and of course, you know, the industry and faculty that have supported these projects, and the students themselves do these presentations. So it's pretty impressive. And in some cases, they continue on into the summer to try to complete a particular project. And one of the other things that we've been doing is we have a summer teacher workshop for high school and community college educators, where we actually spend a week with them and we go over exactly how this program works, and again provide the curriculum for how to do professional skills and also some of these more advanced technical skills in their own classrooms back at their home institutions. So with that, I think I'm going to turn this over to Eric Flynn, who will specifically talk about some of the projects. So Eric?
Hey, can you hear me?
I can hear you. I don't know if every...
Oh, okay, I assume. So I'll just start going.
Okay.
Great. Well, hi, everyone. It's great to be here. I want to just provide kind of a snapshot of a few of our projects, and especially the ones that use additive manufacturing specifically for this call. As you can see, I think this slide just shows how vast and different some of the projects can be. I mean, it's even though this is a manufacturing and mechanical engineering based curriculum, none of the actual applications really repeat themselves. You know, we have stuff that is focused on manufacturing, but we also have electronics and wireless data systems. We have a guitar that was made from scratch, prosthetics for underdeveloped countries using 3D printers. We have a geological survey from the USGS where they printed basically rock fractures or simulated rock fractures. And we also have a project that completely changed the way in which a 3D printer could be utilized. So I'm going to give a snapshot of a few of those. So this is just a quick slide that shows just kind of the level or the levels of technology we have around our different campuses. One of the best things about this grant is we basically utilize the best technology that we can find on all of our 12 partner campuses and some of our universities. So some of the projects, you know, just for prototyping could use something as cheap as a $1,500 Affinia 3D printer. Some of them were using $4,000 MakerBots, and a few of them were able to use and produce parts on a $100,000 plus Fortis 3D printer, you know, that's really made for production stuff. So this first project was kind of, again, a redevelopment of just what a 3D printer is, because we had the idea, and the sponsor had the idea that we could, you know, CNC and 3D printing and basically all of those automated technologies go on the same fundamentals. They use stepper motors and they find an XYZ coordinate system, and they either print or they cut or they machine or they route. So they wanted to develop a kind of a modular system where the frame was constructed in sound and the stepper motors were dialed in, but then you could swap out heads. So you could make a 3D printer head, or you can make a CNC drilling head, or you can make a router head. So, and that entire design was, again, made in SolidWorks. And then this one, again, because of its sheer size, was produced in wood and some metal framing, but some of the small detail work was, again, designed in CAD and then 3D printed. Then again, on a totally different application was this idea of basically a wireless harness system to prevent further injury for high-rise workers. Again, this was brought in by a local Connecticut entrepreneur a few years ago. And, you know, it was a challenge that we didn't even know existed, basically. You know, if you have a 100-story building that you're framing and someone falls, the harness catches them, but no one might notice that they have fallen, you know, and they might not shout because they might have passed out, etc. So this was a completely Arduino-based and Raspberry Pi-based and XB-based communication system that wirelessly monitored the status. But again, being a one-off project, it needed to fit into a system that the harness could work with. It wouldn't be too heavy, etc. So it was designed in SolidWorks, you can see in the upper left, and then 3D printed to basically hold the prototype circuit boards. The Smart Guitar is really exciting because, again, that was brought in by a sponsor that wants to patent the technology and really try to put this into a company, into a startup, hence the entrepreneurial skills that we try to set forth in the projects. Basically, this was taking a guitar, an electric guitar that's been around for, 50, 100 years, I guess 100 years, and put a computer in it and totally kind of change up how an electric guitar could be used. So to do this, not only were, again, SolidWorks heavily used to model the guitar, but also to be able to model a Raspberry Pi screen that could then be inserted into the guitar body and again, protected and encased in 3D printed plastics. And we did it in a way where if the system was ever to be upgraded, you can just snap in different modules that, again, were 3D printed. This, of course, is just a fantastic project. And to note, it was brought in actually by a student. It's one of the first projects where an actual Netsquared student has come back and said, I see a need for this in my country. He's from South America. And he says, it's way too expensive for children to get prosthetics every year because, as they grow so quickly in childhood, they need a whole new system. So he came in with an idea, and again, very novel a few years ago. Now it seems to be running rampant, to basically make a 3D printed system where certain elements would be replaceable as the child grew, but other elements such as the fingers and the electronics could stay the same because, again, the hand would be approximately the same size, plus or minus. So a great system, and you can see that was done on our Fortis machine, the $100,000 one, because just the precision needed and the amount and the quantity, and it came out really, really nice. And the last one was, again, a very unique design. Almost, this was kind of a design that came before the problem. So we don't know if a problem exists yet, but we saw the need to change the environment inside a 3D printer. So very biomedical based, where again, this was kind of a project where we can get some white sheets out of it because we're not sure the application yet. We kind of wanted to design the technology. What it was we took a MakerBot, completely disassembled it, and through 3D printed parts and a few other processes, we made the 3D printer completely watertight. We then hooked up Arduino-based and Raspberry Pi-based processors to control the environment inside the printer, such as it could fill with a liquid, and what that liquid ends up being is really no concern, whether it's a saline solution or a kind of a biomedical type solution. And what it would do is it would interact with the Z platform. So as the platform moved, there was always a layer of this liquid moving with the platform. We also integrated some lights to reflect the idea that you could put in UV lights if you needed it, or ultraviolet or infrared, or etc., just to show that, again, the system was completely controllable. But again, we basically used a 3D printer to make parts for a 3D printer, but pretty cool. Well, that's it for me.
So that's it for Eric. So thank you, Eric. So I think what I would kind of like to wrap up the presentation with is that, again, all of those projects basically were done by student teams. So what we do is the community college students actually pair up with university students in teams of, I'd say, sometimes 5 to 7 students. And they basically, over the course of the spring semester, work about 100 hours is what we tell them is our objective. And then produce, hopefully they address a problem that's presented to them that they have chosen in January, and then work on it. And so some of these projects have actually led to patents, and in some cases, again, we've had very strong support from industry partners that have come back again saying, what you've been doing was great. I think we didn't use the Geological Society, had come in and asked our students to do prototypes on, again, rainwater and drainage. And they just come back and say, oh, this was just fabulous. These students are working just well in teams. We're getting not only, their technical expertise, but, they're demonstrating project management skills that often we don't even see from sometimes graduate students. So that's about the end of our presentation. My contact information is on this last slide. I'll be happy to answer any questions. If you want to shoot me a quick email, also Eric as well, if there's something specific that you'd like him to address, I'm happy to forward that along to him. But with that being said, we're just, again, very pleased that we could be part of this webinar series. So thank you for your participation.